Azure Private Link Overview. Azure Private Link provides secure, private connectivity to Azure services using private endpoints. This eliminates exposing these services to the public internet. Private endpoints bring Azure services into your virtual network using private IP addresses. Traffic between your VNet and the service travels over the Microsoft Backbone network. This presentation covers implementation from planning through production deployment, including Azure CLI commands and configuration details. The focus is on practical implementation steps and architectural considerations for enterprise environments. Architecture components. The architecture diagram illustrates the complete Azure Private Link topology, including on-premises connectivity, hub and spoke virtual networks, and Azure services. On-premises networks connect through ExpressRoute to Azure. The hub VNet contains shared services like DNS infrastructure and resolvers. Spoke VNets host workloads and private endpoints. Each private endpoint provides a network interface with a private IP address that connects to an Azure service. The service provider VNet demonstrates how to offer your own services privately using private link service with load balancers and backend pools. All traffic flows through private IP addresses within the Microsoft Network Backbone, eliminating public internet exposure. A private endpoint is a network interface that connects privately to a service powered by Azure Private Link. It uses a private IP address from your VNet, bringing the service into your private network. Private link service allows you to create your own service behind a standard load balancer and enable private link access. Customers connect to your service using private endpoints. Private DNS zones provide name resolution for private endpoints, mapping service FQDNS to private IP addresses. Each service type requires a specific DNS zone. Key benefits include enhanced security through private connectivity, a consistent networking experience, and no changes required to existing application code. Implementation planning. Planning requires careful consideration of network design, IP addressing, DNS strategy, security requirements, and service selection. Network design includes VNet topology and subnet segmentation. Private endpoints require dedicated subnets with adequate IP address space. DNS strategy involves private DNS zones for each service type and integration with on-premises DNS infrastructure. Security planning includes NSG rules, RBAC permissions, and monitoring requirements. Consider connectivity patterns for on-premises integration. Document IP address ranges, DNS zone names, and security policies before beginning implementation. Virtual Network Foundation. The virtual network provides the foundation for private endpoints. Create a resource group to organize all related resources. The VNet uses 10.0.0.0/16 address space, providing 65,536 IP addresses. The private endpoint subnet uses 10.0.1.0/24, providing 256 addresses. Storage accounts require globally unique names. Adding a timestamp ensures uniqueness across Azure. Choose appropriate SKU and replication options based on your requirements. Standard LRS provides local redundancy at lower cost. Private endpoint creation. Creating a private endpoint involves disabling public access, obtaining the resource ID, and configuring the private connection. Setting default action to deny blocks all public internet access to the storage account. Only private endpoint connections are allowed. The resource ID identifies the target Azure service for the private endpoint connection. Group 1Ds specify the sub-resource for multi-service resources. Storage accounts support blob, file, table, and queue group IDs. Each sub-resource requires a separate private endpoint for private access. Network security configuration. NSGs provide traffic filtering for private endpoint subnets. Create dedicated NSGs for granular control. The HTTPS inbound rule allows TCP traffic on port 443 from the virtual network to the private endpoint subnet. Source address prefix. Virtual network, allows traffic from any address within the VNet. Destination prefix specifies the private endpoint subnet range. Associate the NSG with the subnet rather than individual network interfaces for easier management. NSG rules on private endpoint subnets have limitations. Custom routes and some network policies are not supported. Private Link Service Architecture. Private Link Service enables you to offer your own service privately to customers or other business units. The architecture requires a standard SKU internal load balancer, backend pool, health probes, and load balancing rules. Consumers create private endpoints that connect to your private link service, receiving private IP addresses in their VNets. This enables multi-tenant scenarios and private service delivery across subscriptions or organizations. The standard SKU load balancer is required for private link service integration. Basic SKU is not supported. Load balancer configuration. The provider VNet hosts the private link service infrastructure using separate address space from consumer VNets. Create additional subnets for load balancer and backend services to provide network segmentation. The standard internal load balancer requires a static private IP address for the front-end configuration. Backend pools contain the target instances for traffic distribution. Health probes monitor instance health. Load balancing rules define how traffic flows from front-end to backend based on protocol and ports. DNS resolution process. DNS resolution enables clients to resolve service FQDNs to private endpoint IP addresses instead of public IPs. The client queries the service FQDN. Private DNS zones intercept queries for private link services. The private DNS zone returns the private endpoint IP address instead of the public IP. The client connects to the private IP, and traffic flows through the private endpoint to the Azure service. This process is transparent to applications, requiring no code changes while providing private connectivity. Private link service setup. Private link service requires completing the load balancer configuration, including backend pools, health probes, and load balancing rules. Backend pools define the target instances that will receive traffic from the load balancer. Health probes monitor the availability of backend instances. Only healthy instances receive traffic. Load balancing rules define how traffic flows from the front-end IP to the backend pool based on protocol and port configuration. The private link service references the load balancer front-end IP configuration and provides the private connectivity interface. Private DNS zones enable name resolution for private endpoints using service-specific naming conventions. Each Azure service requires a specific private DNS zone name. Storage blob uses private link.blob.core.windows.net. VNet links connect the private DNS zone to virtual networks, enabling DNS resolution within those VNets. Auto-registration can be disabled for manual DNS record management and better control. DNSA records map the service name to the private endpoint IP address. The record name must match the service name exactly. Hybrid DNS architecture. On-premises DNS integration requires conditional forwarding to resolve private endpoint names from on-premises networks. The architecture uses conditional forwarders on on-premises DNS servers to forward Azure private DNS queries to Azure. A DNS forwarder virtual machine in Azure provides the forwarding target for on-premises conditional forwarders. ExpressRoute or VPN provides the network connectivity between on-premises and Azure networks. This enables seamless name resolution for on-premises clients accessing Azure services through private endpoints. DNS forwarder implementation. The DNS forwarder virtual machine runs bind9 to forward DNS queries to Azure's internal DNS service at 168.63.129.16. The virtual machine requires a static IP address to provide a consistent target for on-premises conditional forwarders. Bind 9 configuration uses forward-only mode to forward all queries to Azure DNS without local resolution. The forwarder enables resolution of both private DNS zones and public DNS names from on-premises networks. Ubuntu provides a lightweight platform for the DNS forwarder with proven reliability for enterprise environments. Traffic flow analysis. Understanding traffic flows helps with troubleshooting and network design validation. On-premises traffic flow involves DNS resolution through conditional forwarding to Azure, followed by application traffic over ExpressRoute or VPN. DNS queries go through on-premises DNS to the conditional forwarder, then to the Azure DNS forwarder virtual machine, and finally to private DNS zones. Application traffic flows directly from on-premises to the private endpoint IP address over the hybrid connection. The private endpoint forwards traffic to the target Azure service over the Microsoft Backbone network. Under a multi-service architecture, enterprise environments typically require private endpoints for multiple Azure services. A centralized private endpoint subnet can host private endpoints for storage, SQL, Key Vault, and custom services. Each service type requires its own private DNS zone with service-specific naming conventions. Multiple private endpoints can coexist in the same subnet, each with unique private IP addresses. This architecture scales linearly as additional services are added to the private network. Security implementation. Advanced security controls provide defense in depth beyond basic NSG's rules. Denying outbound internet access from private endpoint subnets prevents data exfiltration and lateral movement. Log Analytics Workspace provides centralized logging and monitoring for security events. Diagnostic settings capture detailed logs for private endpoint connections and activities. Security monitoring enables detection of anomalous traffic patterns and potential security incidents. Cost analysis. Private link services have specific pricing models that affect total cost of ownership. Private endpoints charge hourly fees plus data processing costs. Each endpoint costs approximately $7.20 per month plus 1 cent per GB processed. Private link service has similar pricing for the provider side with availability and data processing charges. DNS forwarder virtual machines add compute costs but can serve multiple VNets to optimize expenses. Cost optimization strategies include consolidating endpoints and sharing DNS infrastructure across environments. Troubleshooting common issues. DNS resolution problems are the most common issues with private endpoints. Connectivity issues typically involve NSG rules, routing problems, or private endpoint configuration errors. Certificate problems are rare since private endpoints use the same certificates as public endpoints. Performance issues may involve bandwidth limitations or suboptimal routing configurations. Diagnostic commands include NSLOOKUP for DNS testing, Telnet for connectivity verification, and Azure CLI for resource status checks. Implementation checklist. Successful implementation requires systematic planning and execution across multiple phases. Planning includes network design, IP addressing, DNS strategy, and security requirements. Infrastructure deployment covers resource groups, virtual networks, and target services. Private endpoint creation establishes secure connectivity to Azure services. DNS configuration enables name resolution from all client locations. Testing verifies connectivity and security controls before production deployment.